X-ray of wavelength lambda falls on photosensitive surface emitting electron. Assuming neglecting work function, prove that de Broglie wavelength of emitted electron will be root h lambda upon 2 mc. Now we start the solution. First of all, write the photoelectric equation. Photoelectric equation. H c upon my lambda, energy of photon, equal to kinetic energy plus work function. Now given work function is negligible, so W equal to 0. Therefore Sc upon lambda equal to half mv square. Therefore V square equal to 2hc upon m lambda, and the value of V equal to under root 2hc upon m lambda. Now the de Broglie wavelength of electron, lambda E equal to h upon mv. Now put the value of V. So lambda E equal to h upon m under root 2hc upon m lambda. This can be written as h upon m into under root m lambda upon 2hc. So lambda E equal to h cancel, and here the term is root h, m cancel, term is root m. Now the answer is h lambda upon 2mc. This is the de Broglie wavelength of electron. So first of all, use the photoelectric equation Sc upon lambda half mv square plus W. Given a neglecting work function, so W equal to 0. Therefore Sc upon lambda equal to half mv square. Now find the value of V and put this value in de Broglie wavelength of electron. Then we get the answer. Okay, if you have any problem, then write in comment box.